The cardiac cycle is the steps of the heartbeat. So think about the heartbeat, lub-dub. It happens in two parts, and we've already talked basically about these two parts. First, the atria contract, then the ventricles contract. We're going to break this down into further steps to see exactly what's happening as the heart beats. So our first step here, and really this is a cycle, it's a continuous cycle. There is no beginning, there is no end, but we have to start somewhere. So this isn't technically step one. There is no step one in a continuous cycle. But we are going to start with early diastole. So diastole means that the heart is relaxed. So, and this is early diastole, so it means it's in the beginning of its relaxed period. It just finished a contraction. During this time, you have the arteries. So here is your aorta, and here is the pulmonary trunk. The arteries are full of blood that was just pumped into them. So a fraction of a second ago, you put blood in the arteries. There's a little bit of blood left in the ventricles. No matter how good your ventricles are, they will never pump all of the blood out. Think about your ventricles like a tube of toothpaste. You have that toothpaste in there, and when you get toward the end, there's that little bit in there you just can't get out. No matter how hard you squeeze, no matter what you do, you can't get that last bit of toothpaste out of the tube. That's how your ventricles are. There's always going to be a little bit of blood left. This little bit of blood that is left is called end systolic volume. And we can abbreviate this ESV. Systolic means contract. And this is end systolic. So that means it's what's left after you contract. And we are going to put some numbers to these volumes, and it varies from person to person and based on your activity level. So we're going to do the number that is the average healthy adult at rest. But just remember, these are not precise numbers. They vary greatly. In general, this is going to be 60 milliliters, and that is per ventricle. All of these numbers are per ventricle. So you have 60 milliliters here, and you have 60 milliliters here. That's the leftover blood after the ventricle contracts. Notice also that all valves are closed. So you have your AV valves here and here. We can see the pulmonary semilunar valve. You can't really see the aortic semilunar valve very well. It's kind of tucked up under there. But all four valves are closed right now. So early diastole, the heart has just finished a contraction and now it's relaxing. You have blood in the arteries that you just pumped in there. You have about 60 milliliters of blood left over in each ventricle, which is your end systolic volume. And you have all four valves closed. And notice your atria are filling. So veins are putting blood into the atria right now. So both atria are filling up from the veins. Remember, it's while the heart is resting that it fills with blood. Now we can go to late diastole. The veins are still putting blood into the atria. As the atria fill, that creates pressure that pushes the AV valves open. So in late diastole, the veins continue to fill the atria. And the atria get so full that the pressure pushes the AV valves open. So now that they're open, blood spills into the ventricles. Notice we're not contracting yet though. This is a passive spilling. So once those valves open, blood passively spills into the ventricles. Then we can move on to atrial systole. So here your atria are contracting. See here these little lines represent contraction. You can see it's dented in. So now our atria contract. And remember the conduction system. This is when the signal goes from the SA node to the AV node. And remember the gap junctions? As the signal spreads from the SA to the AV node, the signal spreads through gap junctions to all of the muscle cells of both atria. And the atria contract. They have their systole. When they contract, they finish pushing the blood they have into the ventricles. So now the ventricles are full. And this amount of blood that fills the ventricles is the end diastolic volume. Okay, so end diastolic is the relaxed or the resting phase, and end, so it's after the heart relaxes. So notice diastole is over. It's now contracting. We're in the first phase of the heartbeat where the atria contract. So we're at the end of diastole. So EDV is end diastolic volume. That is your ventricles full. And the average healthy adult at rest has 130 milliliters per ventricle. No, I'm sorry. Yes, 130. Next, we're ready for the ventricles to contract. So now we have the ventricles contract in two stages. So we're going to have early ventricular systole, then late ventricular systole. So now that signal is in the Purkinje fibers. Remember, the signal comes down the septum, it gets to the apex, and then it starts to go up the Purkinje fibers. So the apex of the ventricles contracts. And when they do, they push the blood upward. So the blood is now moving up like this. Well, look at those AV valves. See how the AV valves hang down like this? Well, as the blood moves up, it hits the underside of the AV valves and pushes them closed. Now we go into the late ventricular systole. So the contraction moves up the ventricles. So now the upper part of the ventricles is contracting. And this continues to push the blood up. Now the blood's going up this way toward the semilunar valves. So the AV valves are already closed. So now the blood moves up further toward the semilunar valves. And these valves open upward. So see, here's the semilunar valve closed. When it's closed, it's kind of like this. And when you hit it from the bottom, it pushes it open like this. So the blood hits the bottom of the semilunar valves and pushes them open. And then the blood enters the arteries. And the amount of blood that enters the arteries is the stroke volume. And in general, this is 70 milliliters per ventricle pumped into an artery. So if we look at all these numbers here, we had 3 sets of numbers. We start off, we had our end systolic volume, the blood left over, our end diastolic volume, the ventricle when it's full, and the stroke volume, the blood that it pumps out. So let's look at these 3 numbers. You have 130 here is your end diastolic volume. So that is the ventricle is full. So here is a full ventricle with 130. The ventricle is going to contract and push blood into an artery. So we have our stroke volume. That is 70 milliliters into the pulmonary trunk if it's the right, or the aorta if it's the left. Then you have your 60 milliliters is your end systolic volume. This is the blood left over that didn't make it into an artery. Okay, so you start with 130, you pump 70 into an artery, you have 60 left. So anytime you know two of these numbers, you can figure out the third, because stroke volume plus end systolic volume will equal end diastolic volume. So if you know two, you can figure out the third. The other thing we can do with these numbers is calculate the ejection fraction. The ejection fraction is the percentage of the end diastolic volume, which is, remember, the ventricle when it's full, it's your full starting amount of blood. It's the percentage of that that makes it into an artery. Okay, if you think of the heart again like a tube of toothpaste. Let's say you start off with a brand new full tube of toothpaste and it has 100 milliliters of toothpaste in there. And you squeeze as much of it out. And you get down to the end where you can't squeeze any more out. Let's say you squeezed 80 milliliters of toothpaste out of there and there's 20 milliliters left that you just can't get out. Then your ejection fraction would be 80%. You got 80 out of 100 milliliters of that toothpaste out onto your toothbrush. There's 20 milliliters that you couldn't get, and that would be your end systolic volume. So if we do this for the heart, the ejection fraction is going to be that 70 over 130. You started off with 130, you got 70 into the artery. That comes out to about 54%. A little over half. And the ejection fraction, it varies a lot. So somebody who has a weak heart, like if they have heart disease, they're going to have a low ejection fraction. Somebody who's like an athlete, remember before we talked about how an athlete can have a really low heart rate, like in the 40s, because their heart is so strong and efficient, they're going to have a high fraction. Also think about variations in activity. Think about when you have sympathetic stimulation. You know how your heart pounds when you have a fight or flight reaction? Well, when your heart is pounding like that and contracting more forcefully, you're going to have a higher fraction. So remember, sympathetic makes you have more force in your contraction, and that more force will give you a higher ejection fraction.